Again, good afternoon, everyone. I'm Carmen Milanes. I am lead of the Indicators of Climate Change in California program at the Office of Environmental Health Hazard Assessment in the California Environmental Protection Agency. And I am pleased to turn the microphone and the camera over for some brief welcoming remarks to OEHA's director, Dr. Lauren Zeiss. Lauren?
Thank you, Carmen, and good afternoon, everyone. And thank you for joining us today across California and the country. We've got people joining us from, at least signed up to join, from nonprofits, tribes, academia, businesses, county, state, federal, regional governments, foundations. So great to see the participation and welcome all. Some of you may even be joining us from areas that are wildfire prone or that experienced a devastating wildfire. And our last report, Indicators of Climate Change in California, it demonstrates the importance of collaboration and action to make meaningful progress. And it motivates exchanges like this one. And even now, Secretary Yana Garcia is in China to build momentum for cooperation China and climate action. So OEA launched this Bridging Science and Action series at a symposium in January as part of our efforts to track the effects of climate change in California. The symposium convened people across sectors to explore new science and connect perspectives on how to achieve sustainable and equitable climate solutions. And so to continue this conversation, today's event is starting the webinar piece of the series, and it's the first of 6 webinars that we're going to be holding monthly in partnership with other state agencies. And each webinar will feature a climate change topic, summarize current scientific understanding, and showcase examples of efforts to address climate impacts in that arena. So I'd like to thank our colleagues at CAL FIRE, that's California's Department of Forest and Fire Protection, for their participation and partnership in planning and convening today's discussion. And over the next hour and a half, what we're going to hear about is impacts of climate change on California's forests and woodlands with a focus on wildfires, what's being done to prepare for and build resilience of our forests. And so to close, along with CAL FIRE, I'd like to thank Carmen Milanes and the whole Climate Change Indicators team for putting together today's event. So thank you so much. And now I'll turn it back over to Carmen.
Thank you, Lauren. Just a couple of logistical issues before we get started here. Again, welcome everyone. Thank you for joining us. Can we see the next slide, please? We will be holding questions for our speakers until the end of everyone's presentations. Please use the Q&A function on Zoom to type in questions that you would like the speakers to address. We will be saving those until the end and allowing the speakers to present one after the other. If you do have questions or are experiencing issues, audio visual issues relating to Zoom, or have comments for staff to address, please use the chat. So questions in the Q&A, comments not for the speakers to address, or questions, please use the chat. We will try to get to as many of your questions as we can, but please, I apologize in advance if we're not able to capture them all. And just a brief review of the agenda. Today, we have 3 speakers joining us. Next slide, please. We had initially planned this for 4 speakers. Unfortunately, Mario with 3 people is unable to join us today due to some last-minute circumstances. And we will be hearing from our speakers about the latest understanding and relevant data relating to the impacts of climate change on California's vegetation, with a focus on wildfires, and also a discussion of actions underway to address these impacts. With that, I would like to introduce Chris Keithley. He is an assistant deputy director at CAL FIRE, the California Department of Fire and Forestry Prevention, overseeing the Forest and Resource Assessment Program, also known as FRAP. And Chris will be introducing the speakers this afternoon. Chris?
Thanks, Carmen, and good afternoon, everyone. Let's jump right into it. Our first speaker is going to be Jamie Leiderson. Jamie is a senior environmental scientist, also in the Fire and Resource Assessment Program. She serves as the a climate and data specialist for our program. In this role, she supports statewide hazard mapping efforts and works to describe ongoing climate trends and their impacts to California's ecosystems. With over 12 years of experience conducting research focused on fire ecology and forest restoration, with an emphasis on scientific questions that can be applied to natural resource management. Jamie has a master's degree in ecology from UC Davis and an undergraduate degree from UC Santa Cruz. And prior to joining CAL FIRE, she held research positions both at Forest Service PSW Research Station and UC Berkeley. So with that, take it away, Jamie. We look forward to your talk.
Great. And you can see my slides and hear me okay?
Yep.
Great. So as Chris said, I am going to be talking, or I guess he didn't say what I'm going to be talking about. Sorry. So, okay. I'm going to be talking about the upcoming FRAP assessment, which I will say what that is on my next slide. I'm going to be giving an overview of several indicators from the assessment that relate to the broad topics that are the focus of our webinar today. That includes weather, fire, and then carbon and tree mortality indicators. There's a lot more detail in the FRAP assessment that I'll be able to show in terms of both the topics as well as the level of detail that we go into with these. So it's really just a broad overview. And then I'll also highlight some responses from to climate change from a CAL FIRE perspective, which will again be a pretty broad overview. So as Carmen said, FRAP stands for the Fire and Resource Assessment Program. That's the program I work for within CAL FIRE. By legislative direction, one of our core functions is to produce a periodic assessment reviewing the state of our forests and rangelands. We release an update about every 7 years. The most recent one was in 2017, and we are gearing up to put out the next one later this year. This report uses data-based indicators to show the current state and recent trends of the state's forests and rangelands. And our primary target audience is government entities such as the Board of Forestry, other state agencies, and legislators. But we do try to have broader appeal and hopefully be useful to other scientists and interested parties. The first indicator I want to show is average statewide temperature. This is data from NOAA's ClimeGrid data set showing the years 1951 to 2022. And unsurprisingly, there's a significant positive trend. There's been about a 3 degree Fahrenheit increase since 1951. And particularly in the last decade, there have been, most years have had really high average temperature above what the range in the previous data was showing. Annual precipitation tends to be really variable from year to year within California. This is showing the annual precipitation then averaged across the state. And the blue line is the year-to-year data. So you can see those ups and downs and that variability. The gray line is the overall average from 1951 through water year 2023. And then the blue line is the 10-year running average. So despite there being no significant overall trend, we've had an increased frequency and severity of droughts in recent years. and that 10-year running average has been below the overall average every year since 2003. Moving on to some of our fire indicators, this graph is showing trends in the size of large wildfires in California. We define this as wildfires over 1,000 acres. The black line is showing the number of fires over 1,000 acres by decade. It looks really low in the final decade, the 2020s, just because it's not normalized by year and there's only 3 years worth of data in that time point right now. If it was normalized per year, that point would be a similar number to what the 2000s and 2010s is showing. But what really stands out here, of course, is the fire size in the 2020s. It's more than threefold what was observed in the 2010s. And we were already concerned about this in the 2010s when we were looking at this data and seeing, you know, a more than doubling in the 2010s compared to the 1990s. To look at where the impacts from those fires are being felt in terms of different ecosystems, we have an indicator on trends in area burned by vegetation type. This is also by decade and looking within broad vegetation classes, forest, shrubland, grass, and desert. And again, what stands out here is what's going on in the 2020s and that really big jump in the amount of area burned, average area burned per year in forest lands. Up through the 2000s, it was shrubland had the largest extent of area burned, and then that shifted in the 2010s as the rate of burning went up in forest, and then that trend has really accelerated to have a lot of area burned in forest. Most vegetation types in California are adapted to fire, so it's not necessarily the amount of fire that's a problem here. It's actually even with that big jump in the 2020s, this is still less fire than would have occurred historically. But when you run into problems is when you either have fire that's occurring more frequently than what the vegetation is adapted to, which is occurring in shrublands, or when it's when fire is occurring at a greater severity, meaning greater death and impacts to vegetation than what the system is adapted to. So again, it's not the area of fire that's necessarily the problem, but the changes to the fire regime. So the rest of the indicator portion of the talk, I'm going to focus on data from forests. So the wildfire severity, the amount of stand replacing high severity fire that we're seeing in forests has gone up a lot. And this is most of the forests that are burning historically had a frequent low severity fire regime. And there's been an increasing extent as well as patch size of areas that have near to complete overstory mortality. This is a real challenge and a concern for type conversion or forest loss without interventions like reforestation. Without overstory trees, there's no source of seeds to provide natural regeneration. There's also altered microclimate without the overstory there to provide shading. And then as I showed with that first indicator, there's background warming going on. So trees are needing, if we want forest back, they are needing to establish under hotter conditions and more frequent drought. In addition to tree mortality from wildfire, there has been an elevated incidence of tree mortality from drought and insects. This is showing data from the U.S. Forest Service Aerial Detection Survey. And the blue bars are the estimated number of trees to have died in a given year, and the orange line is the area affected. So you can see there was a really big peak in 2016, which was following a hot multi-year drought that occurred in the early to mid 2010s. But the two second highest years are 2022 and 2023. And this elevated tree mortality has been ongoing compared to the early years in the record here. The tree mortality from fire and drought and insects is impacting how our forests are serving as a carbon sink in terms of their rate and ability to sequester carbon. This indicator is above ground live tree carbon sequestration by ownership. The green bars above the zero line are tree growth, and the different colored bars below are mortality and harvest. And so when you have greater tree growth than mortality, you get net sequestration or positive increases in carbon storage, which is what's shown in the black line. So for private lands, growth has outpaced mortality and harvest, and they are still acting as a carbon sink, and sequestering carbon. And then unfortunately on Forest Service lands, there's been a greater extent of fire and mortality, and those lands are not sequestering carbon at a positive rate. They're acting as a source. When you put it all together, overall, the California forests are still acting as a sink, however, as you can see in that last column, which averages everything together. So a couple of things to point out with this graph. It's the data source is forest inventory and analysis plots. That's a network of field plots across the state that is resampled every 10 years. We're moving to a 5-year resample interval, but for this graph, it's still based on a 10-year remeasure. And that means that every year, about 10% of the plots are resampled. So it's comparing the most recent resample year to the 10-year prior baseline. But so some of these plots, the most recent resample was in 2012, which is before most of that disturbance that I was showing from fire and drought and insect mortality. So there's a bit of a lag with that mortality showing up in these data. And then another point that I want to make quickly is just that this is not a controlled experiment where similar forests are distributed among different ownerships and management regimes. So I'm not trying to make the point that all of our forests should be managed as private corporate timberland. This is just a way to assess if what is going on within those specific ownerships. But yeah, there's differences in where they're located within the state, as well as the forest type and the just baseline productivity within the forest. Okay, so to go back to that point of there being a lag in FIA data showing up in trends, this is showing the change in overall forest ecosystem carbon sequestration. So this includes more than just the live trees. It's also got the dead and down and the roots in there. And it's the amount of carbon being stored per year across all acres of forest land. So it's going down, and then you can see there's a really big jump in the last 2 bars there from the 2020 most recent resample to 2021. And that's the first year where those where plots that are after the 2020 fires, which were very extensive, are showing up. So even if there was limited mortality in the next 9 years, this number could still continue to go down as those plots are resampled and averaged into the data here. Okay, so moving away from the kind of more doom and gloom part of my talk, I want to talk about response and opportunities. And I only have a few minutes to talk about this, and there's no way I could cover it all, but the main point that I want to make is that there has been a sea change in recent years with respect to the amount of attention given to wildfire and forest health issues in California. And this has led to widespread efforts to address these challenges. And of course, there's still challenges with implementation, but there is really a lot more energy around this than there were in previous eras, I guess you could say. And then I also will just highlight 3 broad categories of where I think CAL FIRE is responding to challenges from climate change. But again, not going into a really comprehensive level of detail, but just giving some highlights. So the 3 broad areas would be bolstering our suppression resources, increasing outreach to communities and education of the public to help people mitigate their wildfire risk, and then also investments in landscape management and a shift to try to have a more proactive approach rather than reactive to wildfire. This chart shows CAL FIRE staffing by program area from the mid-90s to present. And the green line is overall staff, and then orange is the point I want to make here is how dramatically we've increased our fire protection staff in recent years. In addition to increased staffing, we've increased the amount and capabilities of suppression resources, like equipment, I mean. Some examples would be aerial resources that can fly at night, since fires are now actively burning at night. We recently got 7 new C-130H air tankers, and we also have improved intelligence for early detection and early actions on fires, such as fire detection cameras and aerial resources that can be rapidly deployed for getting better intel on the ground and to increase the success of initial attack. For the outreach to communities component, I want to highlight a relatively new program at CAL FIRE that was started in 2021 called the Community Wildfire Preparedness and Mitigation Program. They have a whole bunch of different things they do. I won't just read all the bullet points. And a lot of these activities are things that CAL FIRE was already doing before this program existed, but this is just to highlight that there is a growing number of staff and people that are focused and dedicated to this as their core job. And then finally, moving on to landscape management. This goes well beyond CAL FIRE, and there's more than I could list here in just a 1-minute slide and just the last minute of my talk. But again, the idea is to have a proactive approach to wildfire management, to do more fuels reduction work and restoration of beneficial fire. An approach for this that is taking off more is to have an increasing emphasis on partnerships. An example of this would be CAL FIRE's Memorandum of Understanding with the Forest Service, established in 2019. That is an effort to collaborate more on fuel reduction and restoration projects to increase the pace and scale of putting treatments out on the landscape, and working with tribes to increase the use of traditional ecological knowledge and cultural fire. Another key program to highlight is the Wildfire and Forest Resilience Task Force. And just a couple points I want to make about them is that they have a regional approach, which I think is important given that we have such an diverse set of ecosystems in our state and different challenges in different areas. And they also have a science advisory panel to ensure that we're using best available science moving forward with changing our management approach. And then finally, there's been an increase in programs providing grant funding to local entities to do a lot of fuels reduction and restoration work. This is not a comprehensive list again, but just some examples to mention. CAL FIRE's Climate and Energy program has forest health grants. They also have a tribal grants program. And at FRAP, we have a forest health research grant program. The Department of Conservation has a regional forest and fire capacity grant program. And then the task force has wildfire resilience block grants. All right, my last slide, I kind of want to end just talking about some opportunities that I see, just to end on a positive note. So it's easy with all the data I showed to see the glass as 90% empty. But I also want to point out that more fire also means more areas burned with beneficial fire. And this gives us a great opportunity for restoration because it can be easier to get in and do follow-up prescribed fire, and a subsequent wildfire is then more likely to burn with low severity and provide benefits to the landscape out there. So just a little plug to not forget those areas and to make sure we're managing those as well as where we're seeing negative impacts. And then I also see a lot of opportunity with reforestation. Our capacity is a challenge given that the need for areas needing reforestation are growing, but there are innovative methods being explored with lower density plantings and managing plantations with prescribed fire in an effort to make these areas more resistant and resilient to increasing frequency of wildfire and ongoing climate change. And then I also see a lot to be optimistic about in terms of there being more partnerships and more interest just across the state, and just the opportunity to listen to and learn from each other. So with that, I will end and pass it on to the next speaker.
Thanks a lot, Jamie. Terrific talk. Carmen, correct me if I'm wrong, but I think we're holding questions till all the speakers have given their presentations. Is that correct?
That's correct, Chris. Thanks.
All right. Well, with that, let's move on to our second speaker then. Our second speaker is Frank Lake. Frank is a research ecologist, tribal liaison, and climate change scientist with the Pacific Southwest Research Station. His research involves wildland fire effects, indigenous knowledge, tribal agroforestry, climate change, and ethnoecology with an emphasis on cultural management, fire ecology of forest, shrub, grassland, and riparian environments in the Klamath-Siskiyou region. Other research includes work with American Indian tribes on climate change, wildfire effects on heritage and cultural resources. In addition, he mentors and serves as a graduate committee member for students working on tribal food security, wildland fire, and forest management. And if that's not enough, he's also a Fireline qualified resource advisor working on wildland fires with agency and tribes. Frank is the Forest Service PSW coordinating scientist to the Western Klamath Restoration Partnership and for the Yurok Redwood Experimental Forest. With all that on his plate, he's managed to make time for us this afternoon. So thank you for doing that, Frank, and I'll pass the microphone over to you.
Great. Can you see my first slide up okay?
I sure can, yeah.
All right, great, thank you. Well, appreciate the introduction and Jamie for helping bring a lot of the things to provide context to my presentation today. So some of the key topics that I would like to cover today are, conducting my research and working with tribes to understand how climate change is impacting their use of forests and forest generally, as well as other habitats associated with forests. What are some of the tribal approaches for climate adaptation, particularly with the emphasis on forestry and fire use? And then what are some of the processes for building resiliency through indigenous knowledge or traditional ecological knowledge, both of the application of fire and forest stewardship through those collaborations? So California is a very diverse state of ecosystems and has a range of different climates has in the past. And so through generations and through millennia, indigenous stewardship or indigenous fire stewardship and those processes and approaches are really diversified as those ecosystems, those habitats, and the very fire regimes that occur in California. Part of that I want to recognize, looking from Northwest California all the way down to the south, is that there's many different tribal groups, different linguistic backgrounds and cultures, as well as the different fire regimes and how the climate is affects in the past, but also presently from north to south, the coast to the interior. And with that, this concept we'll talk about, which is indigenous fire stewardship, are practices that increase the resistance or resilience of both ecosystems, particularly through that use of fire, as well as human communities that inhabit those places and call that help. So some of the current efforts and opportunities in working with tribes are very much through partnerships. And for me, it's been as a scientist. I'm also a Karuk descendant. My half-siblings are Yurok tribal members, so I have a lot of cultural background here in Northern California. But really looking at how do we begin to broaden and strengthen our landscape restoration strategies, how that's informed by the research, how that gets to some of those planning, and then the various management opportunities or opportunities that we can find and create in response to climate change. In responding to some of those climates, we have to acknowledge the past. Part of that's been the past environmental degradation of those areas, acknowledging some of the constraints and also the opportunities working around conservation of species at risk, and now how climate change affect those processes. We need to acknowledge both the strengths of tribal governance, and there's a lot more federal and state consultation processes and recognizing tribal governance in this effort, as well as the diversity of our communities and those socio-ecological systems. I'll talk a bit about what kind of some of the factors are or contributors to resilience, and what are some of the ways that tribes are taking forest management and fire use that can benefit the tribes and society as kind of their climate adaptation approaches. The picture on the right shows me at one of the research plots on the Yurok Reservation. That was a cultural burn conducted by the Yurok Cultural Fire Management Council. And a lot of the perspectives I'll be sharing are in part of my work with California tribes, particularly the Yurok and the Karuk and others. So a key part of mine is, looking at the collaborative research process that can inform adaptive management and also our monitoring to evaluate how we're achieving or meeting our land and resource management plan goals and objectives. What are those of some of the federal agencies, such as the Forest Service or others, state agencies here in California, a range of tribes, non-governmental organizations. I work closely with the Fire Safe Council and other partnership entities. It's important to acknowledge the governance and the leadership of those tribes in that, the different administrative departments working closely with like our natural resources, our fire departments, and the different operational programs they have to support these project activities. For many tribes, at the aspect of their climate adaptation and for fire management is things like food security, human health and well-being, as well as a range of focal species that are important wildlife and plants and mushrooms to them. A lot of this can be evaluated through the achievements that are reflected in the enhanced lands. So as areas are restored and increase the condition and quality of those resources, that benefits the water. Particularly, tribes have the knowledge of the link between vegetation, transpiration, spring flow, and in-stream water beneficial uses that affect a range of both land and water or riverine resources, as well as all the communities that depend upon that. And so as we think about that, how is the more holistic perspective of adaptive capacity considered from working with tribes, particularly around restoration and fire use? Part of my research framework here that informs these strategies and the management is looking at in the full cycle of research, how indigenous knowledge is included into that. So in many ways are learning what the tribes and the tribal community or the public, what are their science support needs and researchable questions, particularly around climate change and forest conditions or resources. Having that indigenous knowledge or traditional ecological knowledge, develop the metrics. So as an ecologist, I might have certain metrics or a forester, like tree basal area, fuel loading, but what are also some important metrics that can be tailored to those studies. That will inform the methodologies about actually how we go about collecting the data, how we go about the analysis, even the ways that we interpret our findings, our analysis, that go into the discussion of, well, we've conducted the study with indigenous and Western knowledge. How is that now going to inform our management strategies or what we do in our treatments? And then out of that comes some important recommendations that are the body of that, creating that best available science. And so with the, the application of those knowledge systems, hopefully to achieve more of the socio-ecological or socio-cultural values in that process. So these are kind of some of my questions I want to tee up and have us consider as we go through this presentation. When we think about what are tribal climate adaptation strategies, what should we consider? So for many ways, what are tribal stewardship practices, such as indigenous fire stewardship, which include management of the resources and fuels, and cultural burning, that can be considered. That increased ecosystem service production or quality and quantity, as well as can also serve as climate change adaptive capacity or practices. I'll talk more about that through the presentation. What are some of the primary considerations for wildland fire management, including indigenous fire stewardship and cultural burning, that can be coupled with both our climate change objectives or goals, conservation, as well as economic interests and values across the state? And then what are other factors or emergent issues that could affect how tribal communities contribute? And this is really a cornerstone of this in promoting drought-tolerant fire-adapted vegetation as culturally significant resources for this process of socio-ecological resilience. And I'll get into some more examples of that. So a lot of my framework here has been kind of looking at tribal perspectives versus federal or state or academic and NGOs on how do we evaluate vulnerability to and the resilience of indigenous knowledge systems, cultural practices that include fire use, how we determine what fire effects climate effects or stressors are taking place on those ecosystem services derived by forests or other ecosystems. So it's just not, it's going to be forest, shrublands, grasslands, also riparian areas are important. And then how do we consider those approaches in our wildfire risk mitigation, our hazard assessments, and also in our climate vulnerability assessments and adaptation plans. And so one of the key things there is how tribes uniquely address this. So for me, we often focus on kind of the Western academic or Western science side on threatened and endangered species or conservation species, economic species. For tribes, it also has that nexus, but also very much it's what are the foods, basket materials, other regalia species that promote and sustain tribal culture, as well as ecosystem services or functionality and processes. How have tribes been represented in this work? I think that's an important aspect. A lot of times there's Western scientists or academics or others talking about tribal practices or potential uses of forest, whereas for tribal sovereignty, having tribes have their own forms of understanding, how they're affecting climate change, how they're seeing the effects of the forest, is having that voice and that representation in that work. For me, a framing of this has been, to describe and characterize what are those tribally valued ecosystems, particularly the habitats and species use of resources. So there's a connection to water for that. A lot of traditional foods from berries, nuts, seeds, mushrooms, a range of other things, materials such as basket material and other resources for part of the tribal arts and culture. Medicines are an important one of that. The regalia are ceremonial use species, particularly the wildlife that are as part of that for the world renewal dances and other ceremonies, and how these are linked to the different forest habitats that include both ceremonial or subsistence practices, as well as economic interests and resources that tie to stewardship and improving the conditions of those, as well as tribal and public opportunities. Part of that is also identifying the climate and wildfire impacts on tribally valued habitats. So, kind of different to the public is I'll talk about being a fire-dependent culture and a range of California cultural diversity, but many species that are emphasized, that tribes use aren't emphasized in existing Western science-based climate synthesis. So there could be hardwoods, non-commercial timber, many forbs for medicinals and other plants as part of those forest resources. And in a way that I've worked in partnership with a lot of tribes on this and academics and other federal and state agency interests and NGOs is having an interdisciplinary or multiple method approach to how we go about collecting and doing our studies. And so having that data to identify what are those climate related threats and stressors. So a lot of the stuff that Jamie presented on the trends and forest change, climate, hydrology, temperature, that all affects that kind of a more of a local scale for tribes of that area or their traditional homelands or Aboriginal and ancestral territories, what's going on there. And that's kind of through the lens of a bottom-up assessment process, looking at those cultural practices for those tribally valued habitats or those species. And then the pictures on the right, part of this is working with both tribal students at that academic level, academic colleagues like UC Berkeley here and the Karuk tribe in this one, doing site level evaluation and assessments at my fixed area forestry plots where I do the ecological study, the tree density, the field loading, but also to bring in that qualitative and quantitative aspect of the tribal assessment of that habitat condition and what we see for climate stress or stressors happening in place at that local level on such resources as foods and basket materials. Part of this evaluation process, can be identified of what's at risk and what are those associated disturbances. So drought impacting both disease or pest, and then leading to extreme fire types of things, how that affects tribal aspects of their ceremonial practices, subsistence, or other commercial interests. What scale is this taking place? Are there individual or family levels? Is it more broadly the tribe or more of a regional trend or effect? Being able to identify and understand what are some of the pathways or the mechanisms of disturbances. So a lot of times in these tribal practices that there's kind of early indications of, well, we see extreme storms or we see the effects of droughts. A lot of that can be evaluated from kind of the bottom up that also match with what we're seeing with broader regional trends in our monitoring. And that in particular could be the effects of drought. I mentioned the pest, and then that increase in size and severity of fires as we're seeing system level change. That's also affecting the tribal community use and living within and part of those systems. So how do we go about doing that? It's like as I described, using some of our Western science research and methodologies and modeling, as well as remote sensing to ground-based plot level data, but also having that traditional knowledge or indigenous knowledge influence and understand and help us interpret and see kind of what those effects are happening on the ground. Some of those are also important to determine the metrics, which I mentioned, how we have alignment in those so we can evaluate how more consistency or some ideas of being able to crosswalk those forms of knowing and assessments. Kind of part of my learning and teaching also and learning this from tribes is that fire is considered medicine, and it's a natural and important part of the ecosystem as well as a human role and responsibility. So for indigenous knowledge, it guides fire stewardship within many of our fire-prone ecosystems across California for fire-dependent species. That cultural burning is a form of human services for ecosystems. So it's that human adaptive capacity, that human agency that affects fire regimes and forest conditions. And it's the evolution of these cultural fire regimes that emerged from indigenous adaptations to form fire-dependent cultures. And what I mean from a natural versus a cultural fire regime is it's the cultural intentionality and use of fire based on that knowledge and other related practices and traditions that affect the frequency of fire, the seasonality of fire, and the specificity of fire ignitions that may differ from natural lightning ignitions, as well as coupled with that. And then really that can vary in space and time by ecosystems, whether we're here in the north, whether we're in the Central Valley, the Sierra Nevadas, down south, that link to those different habitats for those fire-affected resources and values as determined and of interest to tribes. So one of my main take-home messages and points conveyed to me as a scientist and also within my tribal community up here in Northwest California is that indigenous fire stewardship and cultural burning can be strategies for addressing climate change and as human agency and adaptive capacity. We have to recognize the past of, have some reconciliation around the government-endorsed fire suppression and the forced removal of tribal people in their fire use has resulted in increased fuel loads and changes in species composition and habitat structure. Actually, this place here, located at Wichita, California, in the photos, some of my studies on paleoclimate and fire history with other partners has shown that there's more biomass and fuel present now than there has been in the last 1,200 plus the 2,000 years. So we've definitely seen significant changes in time, but more so in the last 150 years because of removal of tribal people, genocide, forced removal. The first Spanish law and the first California law was to limit or reduce and not have Indian burning or indigenous burning. And then we have the legacy of other forest management and fire suppression on the forest today. So really a tribal adaptive capacity response to how we go about this is that cultural burning then as well as now can promote a greater abundance of drought tolerant and fire adapted or resilient vegetation of species of importance as those key resources and for our ecosystem service production and integrity. It's a coupling of this human engagement with the fire regimes that respond to climate change, as it's happened in the past over millennia and generations, but also in regards to how we can promote species diversity, the resistance of a resilience of species among those habitats and between species to have a lot of what we're calling now that heterogeneity or that diversity between different forests and vegetation types, particularly grasslands, meadows, more open forest within what is now really more of a really dense, closed, heavy fuel-loaded forest system in many areas. These approaches can help moderate or buffer against extreme ranges that expand the variation or climate-induced disruptions. So a lot of the studies through the Sierra Nevada and up here in the Klamath have shown that prior to colonization and settlement by Euro-Americans, that native burning and indigenous fire stewardship moderated the extreme ranges of climate, particularly for drought and for the size and extent of fires. And then when that began to be decoupled or removed, we saw a larger increase in fire effects. And so that's some of the studies that help that. And again, these bottom-up practices of indigenous practices. The way that this is kind of shown out here, let me know when I'm at my 1 minute, Chris, is kind of framed in this slide where we have a series of treatments that are both TXT and in fire use that increase from poor quality overdense forest to moving towards a more resilient forest of fire adapted, drought tolerant, particularly on the traditional foods or the other species. And so in this thing, we have related to the concept of pyrosilviculture is indigenous and Western knowledge inform those treatments, promoting those drought tolerant fire adapted species through a series of treatments and fire use that get us to a place of using indigenous fire stewardship and cultural burning as part of that adaptive capacity. My last slide here really is to think about, is these forest fire regimes and cultural practices, the restoration of that a form of climate adaptation, the restorative structure, the composition and ecological, culturally valuable functions of our forests, shrublands, and grassland habitats. For many tribes, it's teaching that indigenous knowledge and fire ecology to tribal youth and maintaining that fire literacy and use in our community, and then focusing around our communities at the wildland urban interface, our critical road systems and around that. But again, restoring and maintaining a lot of those prior fire-affected habitats, montane meadows, oak pine, mixed conifer hardwoods, and grasslands that really were more formally tribally managed and are part of that diversity and resilient capacity of our landscapes. Thank you.
Thanks a lot for that interesting talk, Frank. Again, I'll remind people that the speakers will address the questions at the very end of the webinar. So I see there's been a few questions already posed through it, but I'd like to encourage people to add more questions along the way as they can. I'm sure there's a lot of interesting thoughts emerging from these talks. With that, let's move on to our third speaker, Ryan Tompkins. Ryan is a UC Cooperative Extension forester and advisor for Plumas, Sierra, and Lassen counties. He is a registered professional forester and was a certified silviculturist during his 17-year tenure with the U.S. Forest Service. For over 2 decades now, he's worked on a broad range of landscape level forest and fire restoration efforts in the northern Sierra Nevada region. He's a member of the Science Advisory Panel for the California Wildfire and Forest Resilience Task Force, and has also served on its reforestation working group. His extension education program is designed to serve forestry professionals and land managers, including industrial timberland managers, non-industrial private forest land owners, and public land managers as well. His research interests include silviculture for ecological restoration, post-fire reforestation to promote ecosystem resilience, community wildfire preparedness, and forest management policy and practice. When he isn't practicing forestry, apparently he enjoys skiing with his family, moving rocks, sand, and gravel around his yard. And I'm certainly he would entertain questions on backyard landscaping, maybe at the tail end of the presentation today. With that, take it away, Ryan.
All right. Hey, thanks, Chris. And really, I'll say it's really my privilege to be here with both Chris, Jamie, and Frank. These are professionals who I both know and I admire their body of work throughout the years. So, and hopefully I will touch on some similar themes. I should just ask first, can you hear me okay? And can you see my slides?
Slides look good and you're coming through loud and clear on my end.
Okay, great. Well, good afternoon. I'm starting out with a slide here from the 2021 Dixie Fire. This is burning on the east side of the Plumas National Forest. Actually, I think it's burning up some of my research plots at this point. But I've been in the Northern Sierra, working in the Northern Sierra for over 25 years. And where I live in Quincy, from my front yard, I can see not only the 2021 Dixie Fire, but I can also see the 2020 North Complex Fire, which was equally as devastating, but since it was beat out by acres the following year, it's less talked about. But I want to remind folks that, you know, both of these fires had devastating effects on mountain communities, rural communities, including Berry Creek, Greenville, Canyon Dam, and Indian Falls. And not only is this impacting our communities, you know, many of our natural resource managers live in these communities. And so in many respects, this has become sort of personal for a lot of us that have been working in forest management and forest restoration. I titled the talk Climate Exacerbated Alignment of Density, Drought, and Disturbance. And this is why. Oftentimes in the popular media, when there are large fires, we hear climate change, climate change, climate change. And I do believe, and I mean, there's a body of knowledge showing that climate change is exacerbating these disturbances. But I want to make sure that when we talk with our publics and with our constituents and clientele, that we really need to emphasize that climate change can be responded to in some cases and shouldn't rationalize apathy, okay? And so when we look at the problems that we're seeing here in the 21st century in California's forests, it's oftentimes typified by an adage that is oftentimes taught in fire science. There is a fire triangle where fire needs heat, oxygen, and fuel to exist. We also have a fire behavior triangle of topography, weather, and fuel are the three main factors that drive fire behavior and extreme fire behavior. But in the end, as managers, as humans, you know, the thing that we can have the most tangible effect on in both of the triangles is fuel, right? That's really what our management actions are designed on. And, you know, we can try to modify weather the best we can through good policies, but fuel is really where it's at. And when I'm talking about fuel, I'm not only talking about surface fuels of sticks and needles and debris on the ground, but we're actually talking about trees, both ladder fuels, canopy fuels, because as you can see in this picture, entire forests are burning and acting as the fuel profile. I'm going to start, I really appreciate Frank really covering the ecology that's oftentimes done looks back at historical conditions, but we oftentimes forget that those conditions were created by millennia of humans and human communities interacting with their forests and using processes to manage fuels. And that's probably, or that's what derived these structures that were more resilient to fire. But there's a story that we've all heard and everybody likes to tell about the 20th century. And that story is how we had open forests, as you can see on the slide on the upper left-hand corner. And through fire suppression and harvesting and policies, our forests are far more dense today than they were historically. This is from a study that we did about 2 years ago, looking at what is forest resilience and what is this change and what might be driving these differences in resilience between historic and contemporary forests. This is a graph. They're violin plots. So the width of the violin signifies how many plots are in that axis. And I have 3 forest types here. I have pine mixed conifer, xeric or dry mixed conifer, and a more mesic mixed conifer forests. And for each forest, we have 1911 conditions and 2011 conditions from a great data set that really, thanks to Brandon Collins and Scott Stevens, we were able to utilize. And here, on the very right-hand side, you see differences in competition. These are ecological thresholds of density-related competition. 100% being total competition. If you're above 60, that's what we call the zone of imminent mortality. Above 35% is what we consider full competition. And below 35% is where we have partial to no competition in our forest stands. So these trees aren't competing with each other for resources on a significant basis. And what we found in this study is in historic forests that were far more open, like this over here, 73 to 85% of the stands that you see here in green were in these zones of lower competition. But 100 years later, we see this marked shift where all of our contemporary forests, 82 to 95%, so nearly all of our contemporary forests, were so dense, representing pictures like this, that they were fully competing for resources and they were in the zone of imminent mortality. So let me put some numbers to this. These historic conditions that were recorded down here, this was like 20 to 30 trees per acre. So 20 to 30 trees occupying about the size of a football field. These conditions here that we see here and are typified or characterized by this picture on the lower left are more closer to 140 to 170 trees per acre. And so one of the things that we're really sort of formulating here is that these open, low-density forests really support not only individual tree growth and tree health, but also forest ecosystem health. And that's because historically, when these fires were burning frequently and often, they were limiting the tree competition when the tree competition was 16 inches tall as seedlings and saplings, not 16 inches in diameter as mature trees. And this maintenance of these low stand density conditions really minimizes competition for resources. In dry mixed conifer forests like the Cascades, the Klamath, and the Sierra Nevadas, that finite resource is water. And that's what we anticipate going into the 21st century. And what's important is this low competition, this environment maximizes individual tree growth. So these trees were getting big, not because they were old, but because they never had to compete with each other for resources. And in becoming big, that conferred better resistance to drought, insects, and disease, and also conferred these adaptations with greater resistance to wildfire. So we really think these low densities of large drought and fire resistant trees are really the backbone of the resilient dry mixed conifer forests that we need moving into the future. A colleague of ours, Lex Bernal, published a great paper in 2022, sort of talking about the vision of what lies ahead. And Lex compared these historical conditions that we were studying to future conditions, but future conditions that aren't very far in the future. They're definitely within our lifetimes of 2040 to 2069. And here Lex just looked at tree density and found that, okay, these numbers are in trees per hectare, not trees per acre. But the orange here is equivalent to just 10 to 20 trees per acre. And this larger band, the yellow, is equivalent to 20 to 30 trees per acre. And what she found in her modeling is that as soon as 2040 or 2069, the climate here in California may only be able to support somewhere around 10 to 30 trees per acre. She also found a higher pine dominance looking in the future. And this is what's most concerning to many of us. Her modeling and her data suggests that in this upcoming future condition, the forests that we see today of 100% above ground live biomass, the forests in the future may only be able to support less than 25% of the current above ground live biomass that we see today. And that should be concerning to us all. And we see these trends. Actually, Jamie had great data to describe this picture that we've seen in the central and southern Sierras. But then there's good research from Scott Stevens and many showing that the 2020 Creek Fire was able to burn with, forgive me, I'm not sure if the Creek Fire was 2020. I'm spacing now, but the Creek Fire that burned in the southern Sierras was able to burn because of this high amount of dead biomass created by these drought conditions and bark beetles. And there's some good research from Zach Steele taking this one step further, showing that in this same area in the central and southern Sierras, over only a decade or 11 years, that over 50% of mature forest was rendered to unsuitable forest conditions by a combination of drought and fire. So that's not it. We're also seeing trends in my neck of the woods in the Northern Sierra, where we're seeing high severity fire beget more future high severity fire. This is a picture of the 2012 Chips Fire burning the 2000 Story Fire footprint that was dominated by snags and shrubs. Actually, my wife, as well as some of Jamie Leiderson's collaboration with her, has shown this marked trend that we are seeing, where you take these fire excluded forests, they're exposed to high severity wildfire, they burn at high severity, creating a fuel profile of dead trees and shrubs, and they are prone to reburning, further driving vegetation type conditions from forests to shrublands or grasslands. And you can see this very clearly in this photo deck from the Story Fire. This is after the 2000 Story Fire. You can see regenerating trees in here, some nice black oak. And this same area burned under the 2012 Chips Fire. And you can see that we lost any ecosystem recovery that we were seeing from natural processes. This area still has a fuel load that's prone to burn. So as you can tell, part of our problem in California is a biomass problem. Whether it's green forests and having far too much green biomass, or whether it's in post-fire environments and having far too much dead biomass. And that biomass is fuel. I want to give you some recent management trends. I'll start out at the state of California. It's 105 acres, or I'm sorry, 105 million acres. About 33 million of those acres are forests in California. 20 million are state and federal forests, largely federal. And then about 12 million are private forests. So about roughly a 2/3, 1/3 mix. Between, and I think Jamie mentioned this, between the state of California and the Region 5 Forest Service, there is a shared stewardship goal to treat 1 million acres per year. Actually, I should hand some kudos to Chris Keithley's group that has taken some of both federal and state data and put them together so we can better track them. Before that effort, Clark Knight and myself and John Battles and many others did a study where we looked at what that shared stewardship accomplishment was in terms of footprint. And it was 300,000 acres per year. So that restoration impact that we are seeing in our general trend is less than 1% of California forests per year are restored. Okay, now at the very bottom, you can see in the 3 years that Jamie was talking about in her talk, we lost over 1.5 million acres of forests from high severity fire. So while we might be restoring forests at a rate of less than 1% a year, we are losing 4.5% in 3 years. So we're at a deficit. We're at a calorie deficit or a restoration deficit here. And we see these trends in two zones. The first, this graph is showing both public and private timber harvest over a number of years, over decades, as well as the number of sawmills. And you can see harvests on public timberlands have decreased steadily, as well as so have the sawmill infrastructure in our state. On the bottom graph, we have the state of, both the state and federal governments have put a lot of money towards the fuels problem. And while we are seeing a spike in fuel activity or fuel treatment acres, which is important, when we look at the overall footprint of how those fuel treatment and harvest acres overlap, you'll see that it's a muted effect. And that's largely because the easiest places for us to reduce fuels are oftentimes those landscapes where we've done something mechanically before to remove some of the biomass. This is particularly for forested systems, okay? Not necessarily for grasslands or some oak woodland systems. So I want to be very clear about that. Obviously, I have a pitch here as a solution that we really have to value active stewardship of forest lands in California. And I think the study that I served on the oversight committee for this study with CCST, but this group of authors did a great job trying to articulate the human health benefits of improving forest health in California. Many of you would be familiar with this sort of old adage of like maybe a little bit of smoke here and there to reduce a lot of smoke later on. But I think that the end point is we can't thin our way out of this problem and we can't burn our way out of this problem. They both have negative externalities in terms of public health or ecosystem services, but they also have many, many benefits that far outweigh those negative externalities. And we need to be leveraging both tools to the maximum that we can. So I'm going to leave you with some parting thoughts and what I call some hard truths for California forests. First of all, when you look at these historical, more resilient conditions, Current federal and state forest policies make it very hard to restore to these conditions. Okay, and this is because we have a half a century of federal and state forest policy that has really mandated and incentivized dense forest stocking requirements, whether it's for regeneration or for wildlife habitat. I think we really need to rethink our 20th century conservation biology strategies of protect and maintain, and that they may not be well aligned with 21st century disturbances. And we see this, still in federal forest policy with, some of the new mature and old growth policies coming out. We see this in some parts of 30 by 30. And so I think we really need to value working lands conservation more as we look into the 21st century. The last piece is we aren't coming close to the scale of proactive forest management and prescribed fire that we need. And as I said before, this is a biomass problem that we have, whether you're in the green forests or whether you're in the black forests. As a forester, I remember when we had a vibrant biomass power market for these small trees and submergible trees. And it's somewhat maddening that we still have these policy barriers where we don't have a market when we used to have a very vibrant market 15 years ago, 20 years ago, that many of us remember. And we accomplished good work with it. The last piece is just a reminder, a piece of humility for all of us is that we like to tell stories of land managers before us, of the land managers in the 20th century and their successes and sins. But just as we sort of judge those before us, we too will be judged. And the story that people tell of us in the 21st century will be very different than the stories that we tell of those before. I think it'll be told of how we've lost forest systems on a landscape and massive scale. So with that, I think there's a lot of work ahead. I still have a lot of optimism. I'm sorry for ending on a little bit of motivation. Hey, thank you so much.
Thank you, Ryan. That was terrific. I appreciate that. Let's see, 2 out of the 3 speakers, I think, described the glass as being 90% empty, but still optimistic that we could somehow refill the glass to at least being half full. With that, I think Carmen was going to go through the question and answer period. Is that correct?
That's correct. Of course, I'm happy to share the responsibilities with you, Chris, if you'd like.
Okay, I'll hang on and try and help you through that.
Okay, so thank you to our speakers, Jamie, Frank, Brian. You raised some really good points, and we often tend to talk gloom and doom when we're talking about observational data and climate change, and that's certainly what our 4 editions of the Indicators Report, which CAL FIRE has been a collaborator on, has highlighted. It's a lot of trends that are going the wrong way, but now we've learned that presenting these depressing stories are not necessarily mobilizing action. And I mean, sometimes we have this fatalistic attitude, and it's important to highlight opportunities like Jamie did and how there is hope and there's reason for optimism if we encourage partnerships and work together, have everyone at the table, and tap each other's knowledge and expertise. So I'm going to ask Ryan to come on camera as well for this Q&A portion. There's a number of questions in the chat, and Frank, I see that you've answered a couple of them, so thank you. I am going to start with maybe the more straightforward ones. The first one was for Jamie, relating to your graphic about, and I just lost it. Hang on, sorry. Private ownership, corporate lands showing higher carbon sequestration, and how perhaps there's some bias there because acquisitions by private owners tend to or deliberately purchase the most productive forests in the state, whereas federal ownership includes quality that is both productive and not productive. And whether or not the FRAP assessment looked at this with a lens of site quality so that you're comparing things fairly, apples to apples. Jamie?
Yeah, so that was why I made that point, right? That graphic isn't showing like an experimental result where forests are equally allocated into different ownerships and management. For the FRAP assessment, it's really more of a what and not as much of a why. So we don't necessarily try to like bisect the data down as much like that, but you know, at least within my chapter, I find it important to interpret that stuff within the lens of other literature, you know, showing stuff like higher fire severity on plantations compared to, and you know, and timberlands compared to other lands that are not being managed with that primary objective. So, yeah, I don't know if that. I'll pass your comment on, you know, I guess to others working more directly with the FIA data, but I guess that's I don't know if Chris has anything to add, more assessment, basic assessment wise.
Not in the assessment, but we do report much more extensively to the Board of Forestry, summarizing FIA data. And so I do think we have opportunities there to look closer at the site quality conditions. So that's a good point that was brought up, and we'll take that back to look at as well.
Okay, thanks. The next question could be for all three of our panelists and Chris. The question is, there was reporting that the area around the campfire had been subjected to several fires in the preceding decades. So that didn't apparently serve to protect from the catastrophic fire. Would any of you wish to comment on those circumstances?
Yeah, sorry, I tried to answer that one in the Q&A, but I guess I didn't do it right or something. So Ryan's talk really got at that when he showed that that response of when you get a high severity fire and then you get a big shrub response and you've got a bunch of dead and down wood, that sets up the system to repeat high severity fire. And I believe that is what happened in the area where the campfire started. I'm not super familiar with the, you know, data of that fire, but yeah, Ryan, you've got your hand up if you want to go ahead.
I'll just also mention that, you know, the campfire was a really extreme event with really wind-driven fire behavior. And when we try to design these fuel treatments, it's oftentimes designed for like 90th or maybe if you're lucky 95th percentile fire weather conditions. And there were just some really, really challenging weather conditions in that campfire as well.
Okay. Perhaps related to that is a question relating to what key phrases can be used to encourage timber preserves to drop the standing burned trees that are like standing matchsticks. Maybe Ryan, could you address that?
Well, I also want to emphasize that the dead trees do have ecological value, whether it's wildlife habitat. I think what we need to look at, though, is it all depends on scale and context, right? And so we know that these forests are overly dense in many cases. And Loretta had another good question about like, hey, we know many of these forests were more open and perhaps maybe park-like in some settings, but just very open, maybe even savanna-like. But that doesn't necessarily negate that there wasn't pockets and this idea of heterogeneity and denser areas on the landscape as well. And the violin graphs that I showed do show those tail ends. But I think the difference is is in context and scale. Is historically the vast majority of these forests were open with some heterogeneity of denser conditions with dead trees and those types of things. We have shifted the other way, where the vast majority of our forests are very, very dense with very few open forests in them.
Frank, I'm wondering if you'd like to offer your thoughts on that.
Yeah, I had one go back to the unfortunate history of how some of the timber barons acquired their land. I don't know if it was necessarily purchased or it was through forced genocide of Native people, and then there was militia groups that had the interest of those white settlers for the timberlands that then were requesting reimbursement from the state and the feds. And part of that payment, because they couldn't make it, was land grants that became the productive timberlands. So I wanted to kind of have a little reflection on the reconciliation of how the most productive timberlands in California were acquired or purchased. So just a bit of that history. And then the second one, a part of that to this heterogeneity part was a lot of those most productive grasslands for settler grazing were those complex, what we're now calling complex open early sterile, that were the open forests that had productive areas of springs and meadows and grasslands that were an important part of indigenous stewardship and managed areas outside of villages. And so when we think rolling back, what was the historical distribution of forest types, stand age classes, the diversity that's now been more homogenized because of other factors like fire exclusion and industrial forest management in many cases that have promoted fire suppression to protect the timber resources that are now overstocked. It's that tribal lens that looks at what were those factors or processes that maintained that heterogeneity. And a lot of it had to do with maintaining complex open forests with a lot of understory diversity, more light for understory production, and that diversified fire regime or cultural fire regimes. So anyways, this is kind of putting that all in the context for when we look back at his story, understanding the nexus with Native people, land tenure or ownership, and kind of the conditions of forest management and fire management that affected where we're at today.
Thanks, Frank. I see a raised hand. I think we would prefer that you type your question in the Q&A, please, so that I don't know that we have the ability. Maybe we do, but we would rather have your question typed into the Q&A. So hopefully this is a quick question again for Jamie. Wildfires offering an opportunity for restoration and regeneration. Do they help clear any invasive species that may have taken hold in the preserves, parks, and forest land? Is this kind of land cover, well, something Cal EPA, it wouldn't be Cal EPA, it would be Cal Fire, would measure?
Yeah, I think it's really key that we have monitoring on these. I haven't seen any studies that show that they're making invasive species worse. I'm not super familiar with the literature on it, so I don't want to give a definitive answer, but I do just want to highlight that, especially if we're increasing the pace and scale, we need to be monitoring and making sure that we're having the impacts we want and reducing unwanted non-native species. Yeah, I don't know. Does that answer it? And I think it depends on the ecosystem too, right? Like fire is used in grasslands to reduce star thistle, for example. I don't think in like reserve areas and forests, yeah, I'm not sure. There's probably issues with it probably depends a lot on the species and on the ecosystem. So
maybe this is off base, but Frank, I found it very notable, your quote, fire is medicine. Is there anything related to that that might relate to this question?
Well, yeah, I think sometimes it's like it's sharing a tribal philosophy, or we have a philosophy or a value, but how do we operationalize that? And for me, it's deeper cultural and spiritual relationship of the reverence for fire, but also fearing it in some ways amongst the California tribe groups I work are familiar with. And then so in that regard, it's that nexus with prescribed fire, or how do you give the right amount of dose? And a lot of that, I see kind of a theme through some of the questions are, historical conditions have changed to where we're at now, and we're going to go into a warmer drying trend, a more densely populated California. Things the question in here about home hardening versus defensible space. I think for a lot of the tribes, it's again that notion of what is the adaptive capacity of individuals that are supported by other entities such as government and federal agencies or organizations. And so I think in regard of where I'm looking at from my work with tribes is they've learned to live with fire. And it's something that still is coming around as a more philosophical notion for our California residents is, can we suppress our way through it? Do we actually have the tools? When Ryan talks about the amount of the pace and scale, we're not meeting that pace. But what does it take in a whole shift in our society philosophically to modernize, adapt in a way that we live with fire? I mean, it could be everything from land use planning, zoning. If unfortunately towns are burned through, Zeke Lunder gave a great presentation at the Association for Fire Ecology Fire Congress on looking at how our towns are laid out and how those actually are conductive to fire spread from the wildlands in through the communities. And so there's a lot of deep thinking to address these crises or these wicked problems that we have that are going to be a longer term view than just 1 decade. Again, it's an intergenerational approach to learning to live with fire and adapting to climate. Is our society willing to accept that challenge and try to learn to live with fire in a way that is going to be some changes to our overall structure and society? And I think that's the harder one that we have to kind of grapple with. And so for me, we kind of have to rethink, how do we live with fire? Because the fire-prone ecosystem is likely going to be for another couple centuries, if not millennia. So what do we do now that will set up, and again, in tribal philosophy perspective, seventh generations or learning to live with fire, fire's medicine, how does it become an essential part of our society rather than something that's feared and always seen as negative?
Thanks, Frank. Here's maybe a straightforward one, and maybe something that we could offer later on as additional references and links. Where can members of the public learn more about reforestation efforts and get involved with and/or support them? If any of you would like to offer up some resources, or we could follow up later with a compilation of ideas.
I'll be quick. I know the California Wildfire and Resilience, Forest and Resilience Task Force has a reforestation working group that has drafted a strategy that has gone through both CAL FIRE, the Forest Service, and I think is now being reviewed at CNRA. There are a number of partners. We have a new reforestation pipeline project cooperative that is being led by American Forests. Many of us are members, where we try to get folks who are reforestation practitioners together to talk about how we share seed, how we share, how we find cones, how we can really expand our capacity in reforestation because it's desperately needed. And then the last I would say is there's many of us that are working on this idea of what climate-informed reforestation is. As we know, we're planting trees that are going to have to grow in a much different future. And so we're certainly weaving in themes of resistance to disturbances and fuel reduction into plantations, and really changing how we think about planting trees as really planted fuel breaks, if you will, that will be more resistant in the future and hopefully be able to throw a cone for the future disturbances so they may be more resilient.
I'll add a part there from a lot of the tribes, and we especially look back through our studies of forest density, is to promote, again, a lot of the fire adapted drought tolerant vegetation. And that means less tree density. We see trends moving towards more pines. So if you take a fir compared to a pine, the stomatal conductance, the shutting down, the reduction of use of water is a key component. Also, in looking at hydraulic redistribution between big old oaks and their deciduousness, in many cases, black oaks and other ones like that, are a way of thinking about, the persistence. When we think about restocking, a lot of that conversation comes around from conifers. But for many tribes, it's like restocking or re-promoting the reestablishment of the hardwoods and some of those drought-tolerant pines or cedars. And so that's one of the things is to think about, and it ties back to one of the questions on water use, which I wanted to get to, is when we think about, the supportive capacity of the future forests based on soil moisture regimes and availability of precipitation to provide that water, we're going to have to probably strongly consider a much more open forest. And within that composition, we're going to have to think about what species are more drought tolerant and fire adapted. And then within that, also the structure of our architecture that provide other forms of habitat or services like shade or acorn or nut production, berry production like the madrones. And then that understory species that maybe have differential water use and put that all together. You know, one of my early work in looking at the connection from a tribal perspective to fire, to forest, to water yield, to fisheries, so I started off as a habitat fish biologist, was the understanding that we used to have a lot more perennial springs, and now because of tree density, and now we lost some of that perennialness to intermittent, that fuel loading then allowed fires to spread. And now that we've had these much larger high severity fires, we're getting the water back, but it's almost an excessive amount of water. And we have mass erosion and hillsides that are also affecting that, but we get some of the water return. And so there's going to be this proportionality and the balance of, you know, what is the right dose or amount of fire to promote a more open forest, to think about water as one of our most critical resources across California, that groundwater recharge, how that vegetation accesses its water, near surface or ground, and then what that provides for downstream beneficial uses, whether it's our municipal water districts or our agriculture and our in-stream beneficial uses for fisheries and other uses.
Thank you, Frank. We have a number of outstanding questions in the Q&A that with the remaining 3 minutes, I don't think we can get to without committing any of our speakers' time. What I would like to suggest is we're going to capture all of these questions, and if our speakers are so inclined and have time, if you wouldn't mind addressing them in an email, that would be a way to go. Some of the points will take some time to address. So, or you can take the last couple of minutes trying to type a response in the chat. That's another option. But I do want to wind down. Thank you so much for your perspectives, your excellent presentations. Thank you so much for the questions, some of which are quite provocative, thought-provoking, not provocative. And we thank everyone for tuning into today's webinar. I would like to thank our colleagues also, in addition to the speakers, our partners at CAL FIRE, Jamie Rich Walker, who is not here with us today, and Chris Keithley for helping us frame, plan, go over all the details of this afternoon's webinar. We really appreciate your efforts. And I would also like to acknowledge the efforts of the OWIHA Climate Change Indicator team, Tamara Kadir, Emma Tanner, Bennett Locke, Lori Montserrat, and our IT support for all their help in making today's first webinar of the series happen. And speaking of our webinar series, on the next slide, we would like to invite you all to tune in to the second of the 6-part webinar series. The next one will be focused on hydroclimate. You know, just as all of us in California have felt the impacts of wildfires in the past several years, we all have been subjected to this weather whiplash the past couple of seasons at least. We will be exploring the impacts of climate change on California's water resources and highlighting some examples of what's being done about it. There will be a link in the chat for information on the webinar series, as well as to register for the webinar. And with that, again, thank you so much for your attention, and thanks to the speakers for their excellent presentations and discussion at this afternoon's webinar. Have a good afternoon, you all.
Thank you.
Bye.